Single replacement reactions have the following form. An element reacting with a compound to form a different compound, and a different element is released. A story I always tell in my classes is something like this. Let's say you and your date, that's you right there, decide that you're going to go bowling. That's what a lot of teenagers do. Most teenagers on a weekend, that's pretty much all they do is bowl. So you and your date decide you're going to go bowling, and your friend doesn't have a date, and you feel a little sorry for your friend, so you say, you know what, why don't you come on with us? Come on, it'll be fun. Your friend says, no, I'd rather stay home and read Macbeth. And you say, oh, don't be a noob. Come on, it'll be fun. So finally your friend decides, okay, I'll go bowling with you. Well, something happens at the bowling alley. Your friend bowls a 247 and you bowl 38 or something. And in any case, at the end of the night, what happens is, here's you, and here's your former best friend, and here's your former date. That's a single replacement reaction. Somebody starts out alone and horns in on a couple. One of the members of the couple ends up all alone, and we have a new couple at the end. That's a single replacement reaction. Let's write the molecular and net ionic equations for the calcium hydrochloric acid reaction. Well, if we have calcium, that's obviously simply Ca, and hydrochloric acid has the formula HCl. You might recall that a molecular equation is one in which there are no ions shown. Everything is written in neutral form. This is a single replacement reaction. Calcium playing the part of your friend, and chlorine playing the part of your date, and you are represented here by the hydrogen, who initially was matched up with your date, and then at the end of the evening you can see that you go home alone. That's the molecular equation. The net ionic equation is going to eliminate any spectator ions, and we know that hydrochloric acid, H plus and Cl minus ions are actually separate from each other, and if we look on the product side, calcium chloride is a soluble compound. In short, the chloride ion is a spectator, and the correct net ionic equation would look like this. The activity series is a list of metals, and here is the activity series, or a activity series. Please feel free not to copy that down. At the top of this series are the highly reactive, so-called active metals. The active metals easily lose electrons, and if you look at the top here, you should recognize some elements that probably lose electrons fairly easily. Lithium, rubidium, potassium, barium, and so on. At the bottom are the not-so-reactive noble metals. They can lose electrons, but they don't very easily lose electrons. Gold, platinum, silver, and so on. Now, how does this relate to single replacement reactions? What tends to happen is that elements that are higher up on the activity series can, in essence, steal dates from elements that are lower down in the series. For example, let's say that you are magnesium, and you and your date decide you're going to go bowling, and you want to ask one friend to go with you. It would be unwise of you to ask any of these up here to go along with you, because what's going to happen is they're going to steal your date. On the other hand, if you're magnesium, and you and your date are going to go bowling, and you're going to ask your friend to go along, if you ask any of these friends to go with you, then you're going to be fine. They're not going to steal your date. Let's try an example. Which of the following metals will reduce PbCO3? Now, what do we mean by reduce? Well, reduction is gain of electrons. So, what we need to happen is we need for this Pb2 plus ion, which is what we have in this compound, to be reduced to Pb. We need to find a metal that will kick Pb2 plus off and separate it so that it's just Pb. In other words, carbonate here, the CO3 ion, is the date, and we need to steal that date. So if we find lead right here on the activity series, we need to choose a metal that is above lead, and that's going to be magnesium.